Hello everyone. I'm going to talk about what is CNC programming and what are all the machines that I have seen in my internship to the industry that I visited in. So let's get started. Okay, so let's start with CNC programming. What CNC programming basically is? CNC refers to computer numeric coding, where the codes are used to operate a CNC machine to control machining components with repeatable accuracy. CNC is a method of functionality where the machining components are being controlled by numeric codings, where the computer is being used to produce sets of codes which can be used for the control of the machinery components to produce a desired product as a final product that we should get. It is widely used in many industries to produce 2D components, 3D components, and many other complex structures which cannot be obtained by normal conventional human methods. CNC is basically a subtractive manufacturing process as like all the other manufacturing process, which involves removal of material from the stock. Okay, let's see what are the advantages of CNC machining. It can be used for easier programming, like unlike the other normal conventional methods. A person who knows basic programming of G and M codes, which we will see later, can be used for finishing a time-consuming process in very small amount of time. It can be used to avoid major human errors also. It's safer to operate given the person has to know about how to operate the CNC machine. It reduces the manufacturing time, obviously. Complex geometry of material can be easily obtained rather than which is harder to obtain in like conventional methods. Higher accuracy of dimensions are obtained unlike the conventional method. Let's see the types of CNC machines that is currently being used in industries. First is based on the motion of the machine, point-to-point motion. This involves the movement of the machinery parts like the cutting tool or the spindle or any other movable part present in the machine from one point to another point, depending on the user's wish. If he decides to move the move the tool from one point to another point, it's that type of motion of the machine is called point to point motion. And on the other side we have continuous path, where the movement of the CNC machine is not stopped at any point or any given reference point. It moves on a continuous like a circle or a full straight line, whatever needed by the user. Next is based on the control loops. There is the open loop and closed loop, two types of systems based on the control loops. First, when we move on to the open loop, it is the open loop refers where the machine, the CNC, that is the NC machinery, obtains the code from the user and it then gives out to the driver, where the code is being compiled and it decrypted, and it is given to the motor, where the motor functions the movement of the tool, the rotation of the tool, etc. And that's the end of the open loop system. When it comes to the closed loop system, the same process, the same is done in the beginning. That is the driver gets the input from the user and it gives the compiled version of the coding to the motor, and it does not stop there. It gives a feedback to the closed loop system, the controller, which is the user. Like we get a simulation of the thing that we intended to get, which helps us to make sure that we get a desired outcome. So this is the difference between the open loop and the closed loop system. Based on the positioning of the system, incremental and absolute, which we will see on the upcoming slides. Now let us see the principles of a CNC machining. All CNC machines can control their machining parts in various degrees of freedom. These degrees of freedom is called the axis of the CNC machine. Each CNC machine, like CNC lathe, vertical milling center, drilling, there are many CNC machines, each have their very own various number of degrees of freedom, which is basically known as the axis of the machine. These are the axis is nothing but the movement of the tools that are defined in X direction, Y direction, or Z direction, depending upon the machine that you are using. CNC machines have both linear axis, where the movement of the tool is in a straight line, the linear motion, and rotating axis, where the movement can be rotary or in a circular or three-dimensional path. Coordinate systems of CNC. There are basically two different coordinate systems that are being used in CNC machines. One is the absolute coordinate system and another one is the incremental coordinate system. In absolute coordinate system, the origin of the cutting tool that is being used is changed on each time when the tool is moved. So basically, when what to say is, if we have a cutting tool that is at 0, 0, that is the initial reference origin of the tool. So let us say I ask the machine to move the what to say the cutting tool to 0, 5, that is 0 in x direction and 5 in y direction. So it moves the tool from in 5 units in y direction. So now I ask the machine again to move the tool to 10, let's say in y direction 10. So what it does is it moves the tool to y at 0, 10, not to 15. Like the value is not incremented, it's the absolute value, like 0, 10. The 0, 0 is the fixed origin for the tool in overall machining process. So if you give us a value to move it to 10, it moves to the exact 0, 10 of the origin, the plane. It does not move to, like if I say move to 10, it does not add up the value to from 5, giving it out of 0, 15. So that is what incremental coordinate system does. It increments the value that is being given as the input. If the initial value is given taken as 0, 5, and I ask the machine to increment it to the value of 10, then the value 10 is added to the y direction, giving out the final position as 0, 15. So that's the basic difference between absolute coordinate system and incremental coordinate system. Now let's see how CNC works. CNC machining is done with the help of sets of codes which are called G codes and M codes, where G stands for geometric codes and M codes stands for miscellaneous codes. These codes are used to control the parameters of machining parts like depth of cut, feed rate, spindle speed, coolant releasing, etc. These GMN codes are basically what to say generated by computer softwares. There are various softwares that is available in the market which are used to provide these GNM codes, or by skill and knowledge one person can write a GNM code by his own skill. Now the movement of the axis and cutting tool of CNC machine is controlled by these codes. Yeah, so basically the G codes and M codes are used to control the movement of the axis, the movement of cutting tool, the speed at which it should cut. All those parameters are being controlled by these G and M codes. All CNC machining has a part program which are compilation of these combination of these G and M codes, which are sequential instructions of given to the machine. The G and M codes are given to the machine to function as per required by the user. Now comes to the main part of my presentation, which is CNC vertical milling machine. This is one of the machines that I saw in the internship that I did in the industry that I went to. Okay, so let's now get to know what CNC vertical machine specifically is. The CNC vertical machine is a machine which is used to do some subtractive manufacturing process like drilling. Many other works can be done in it. So let us see what are all the specific features of it. The axis of the machine is vertical and is perpendicular to the surface of the workpiece. So the workpiece is kept on a table, stationary table, where the workpiece is fixed. The cutting tool is moving, which can move in X, Y and Z directions. It has 3 axes. So depending on the user's input, it can move the cutting tool, and it is perpendicular to the plane of the workpiece. Here the workpiece remains stationary and the tool rotates. It has 3 to 5 axes depending upon the model of the milling machine. The machine that I saw in the company had a 3-axis vertical milling machine, which has the X, Y and Z direction of axis of motion. The basic CNC vertical machine has at least 3 axes. The minimum is 3 and the maximum is 5 till date. The price can be estimated around in Indian rupees 2 lakhs or even more. Now let us see the uses and advantages of a vertical milling center. A vertical milling center can be used for cutting, drilling, carving, engraving, tapping, boring, etc. All these processes can be done with the help of a vertical milling center with ease of access. It can be depending on for each of these processes, a specific cutting tool should be replaced in the spindle. Complex curved parts such as cams, engine impellers, propellers and all these stuffs can be. There are pull rods in tractors which can be manufactured with the help of these VMC easily with the help of simple sets of G and M codes. And these vertical milling centers are smaller in size, which can be attached in stored in a simple small room. Doesn't occupy much space. They are available at lower cost as they are comparatively cheaper too compared to any other CNC machining like CNC lathe, etc. CNC lathe initially starts at a price like 7 lakhs, 6 lakhs. When compared to that, vertical milling center is way more cheaper. Okay, let's see the tools that are used in a vertical milling center. End mill cutter, face mill cutter, involute deep cutter. These are the basic three tools that are used in all industries which has a vertical milling center in it. The basic cutting tool uses an end milling cutter, which is basically used for putting holes, drilling, or engraving and stuff. This cutting tool, the end mill cutters, all these cutting tools are made up of high-speed steel HSS. Now, these are the specifications of the vertical milling center that I saw in the industry that I went for the internship with. The brand they used is the Fanuc. The model number is AT21IEL, which had 3 axes X, Y, and Z. The Z travel speed is 330. The spindle speed can be up to 10,000 RPM. The spindle power that the VMC used, it had 2 phases of power. The initial phase, first phase had can withstand up to 5.5 kilowatt, and the second phase can withstand up to 3.7 kilowatt. The x-axis travel on the table is 700 millimeter and the y-axis is 400 millimeter. So these are the basic specifications that were given for the VMC that we had in the industry. Okay, so the program input to CNC machines. The program is inputted by the method of manual data input method, in which the user is hired who has the knowledge of writing a G and M code and verifying it. So he sits on the table and sees all the codes, makes sure everything's okay according to the end result that we have to obtain, and this is double checked with the CAD diagram, the computer aided diagram of the design that is going to be fabricated physically. These CAD diagrams can be helpful to produce G and M codes within the diagrams itself with help of the softwares like NXCAM, MasterCam, which can generate G and M codes directly from the CADs, which can be incorporated into the CNC machines to continue the fabricating process. Now let us see the basics of CNC programming. There must be order and functionality in the code that defines the particular machining process for the machine to execute. Yes, obviously. Writing a G and M code and incorporating it to the NC unit, there must be order that has to be maintained so that the machining process is done without any error or any other trouble. So the person who is incorporating the codes into the unit must know what is the order and what are the function of each and every code. So that has to be followed. G codes are required for the geometric operation of CNC machine parts, as we already saw. G codes are used to determine the motion of the axis, the motion of the cutting tool, etc. M codes are used to aid the G codes, like coolant oil on or off, rotation, starting and stopping of the rotation of spindle, at which speed it should rotate, etc. Controlled by the M codes. There are axis codes like X, Y, Z axis codes, which are used to determine the motion of the cutting tool in the respective X and Y and Z axis. If you want to move the plane at X direction in phi, so you have to give the notation as X 0, phi, in Y 0, 4, and in Z minus 0, 3 respectively, according to the user's wish. And there are the extra specific codes like F code, S code, U code, and W code. The F code is used for giving a specific feed rate according to the user. S is for the spindle rotating speed. The RPM can be given along this code. Like if you give S 1000, it means that the RPM of the spindle must be 1000 RPM. The U and W codes are nothing but reference position. Like if you have a fixed origin, for example, in absolute positioning, we have a fixed origin 0, 0. But instead of 0, 0, if you want to take like 5, 16 as a new reference point, then in U and W, in U you should give U 0, U, 5, and in W you should give W 16, so that you get the new reference position 5, 16 as the new origin. So that's what use of that code is. CAD and CAM always plays a major role in modernizing modern industrialization, as it is widely used in almost all manufacturing industries to produce products. Nowadays, all the manufacturing industries like mechanical, productive, electrical, most of them use the help of CAD and CAM analysis to do simulations and stuff to check whether the production of the product is safe before actually physically doing the process. In that place, CAM plays a major role. Nowadays, any type of complex materials can be produced with the help of CAD, because CAD is basically a virtual product designing, so you can check the dimensions, you can analyze the each and every element like the stress, the force acting on it, so you can double check before actually getting the product to be produced. CAM plays a major role in many industries like mechanical, electrical, and aerospace engineering. In mechanical, in places like which uses thermodynamics, fluid dynamics, solid mechanics, and kinematics and robotics, CAM plays a major role. In robotic industries, CAM is the only thing that has been used till date. In electrical industries like electricity, electromagnetism, and electronics, there are some CNC machines that are being newly produced for which has electromagnetism in it to do the specific electromagnetic work that has to be acquired by the user. So that's all about the presentation that I had to do. So thank you.